Amish God demands that we learn math. Amish God demands that that announcement is over. We begin!
Here we go, you guys. So, we are doing nothing new today. Isn't that awesome? Nothing new. Hey. Okay, let's see. Alright, so here's what we are doing. We are going through and we are reviewing all the different types of factoring we have already done over the last couple days, because what's going to happen is instead of being given directions to factor using a specific method, it's just going to say factor, and you have to figure out what kind of a polynomial you have and how to factor it. So, here we go. The very first thing that you always want to do is look for a greatest common factor and factor it out. Once you have done that, you want to look at the number of terms you have, because a lot of times that will help you identify what type of factoring to use. So we have a few different options. The first one is that you could have two terms. Okay, so if you have two terms, we learned three different types of polynomials that are factorable because they start out with just two terms. The first one is a difference of two squares. So difference of two squares, let me give you an example of that. So, let's see. Just keep this up here. How about if you have something like x squared minus 100? Does anybody remember how that's factored? I don't think I need this. Alyssa? Good. So we have one x in one parentheses, one in the other. Okay. 10, good. Okay, and then what's the only way that we're able to get a negative when we multiply? Perfect. All right, everybody give it up for Alyssa. Okay, two terms. Next. So that's one of them. Another one we learned yesterday, and that is the sum of cubes. Sum of cubes. So x cubed plus 8. X cubed plus 8. Those were those formulas that I told you all you should memorize, remember? Thane, you remember how to factor this?
You write x plus 8.
Or what is the cubic root of 8?
2.
2. So x plus 2. Good?
X second.
Good?
Plus.
It's minus. Good.
Minus 2x.
Good.
Plus 2 squared.
And what is 2 squared?
4.
Excellent. Everybody give it up for Thane. Nicely done, Thane. All right. What is the last one? We have difference of two squares, sum of cubes. What was we had one other cube. What was that? You guys remember from yesterday? Zach?
Diamond thing.
We're going to do that as well, but so we have a difference of cubes. So this is where everything is the same, except instead of it being x cubed plus 8, it's x cubed minus 8. So does anybody remember from yesterday how that would be factored? The only difference here is the signs. X cubed minus 8. Brandon? Good? All right, everybody give it up for Brandon. Done. Okay, are there questions on those first three? Again, this shouldn't be brand new to all of us. We've been doing these over the last few days. So, that's if you have two terms. So this is how you're assessing. When you see a problem, if there are only two terms in it, you're probably going to be doing one of these three things. Okay? Then, the next option, you guys need that still? There. Okay. So then the next option, you're good now? Is everybody done with that page? Yeah? Okay, so then the next option is that we could have three terms. So 3 terms. And this is what Zach was talking about. If we have 3 terms, we have a few options. One is use the diamond method for non-perfect square trinomials. So, diamond method. So let me give you an example here. Let me just make one up. How about x squared plus 7x plus 10. Can somebody help me complete a diamond for this? X squared plus 7x plus 10. So, who remembers what goes in the top? Tyler?
A times C.
Wait, what?
A multiplied by C.
Oh, good, A times C. So 1 times 10 is?
10.
10, okay, and then what goes, who can tell me what goes in the bottom? B, which is Aiden?
7.
Or Officer Ordonia?
Wait,
It's, oh, I did not. Amish God, right? Okay, you're gonna have to shout your names out, because otherwise I will not remember. Okay? So the bottom goes 7. All right, so everybody think of two numbers that multiply together to get 10 and add up to 7. Vanessa? / Ladybug. Good. Everybody give it up for everybody who just helped on that. Okay, then what do we do from here? Alan? Good. Distribute it to what? The 5 and the 2. Where do these get placed? On the top. We're creating little fractions. Everybody give it up for Alan. Okay, and then, so that's the second to last step. So as long as these cannot be reduced, can somebody tell me what my final answer is? Rebecca. Excellent. Everybody give it up for Rebecca. Okay, now, that is if you have something that is not a perfect square, but you will have perfect squares here. So perfect square trinomials. So let me give you a couple examples of these. So what if we have something like x squared plus 10x plus 25? X squared plus 10x plus 25. This is a perfect square trinomial. Now, can somebody remind me how I can verify that? So we had notes on that. Samantha?
The first and third term are both.
No, you're right.
They're both. They
Per-
can both
perfect
be
squares.
square roots, like this. And then
So what is the square root of x squared?
x.
And what's the square root of 5?
5, and then b is 2 times whatever the square root of the third term is.
Cool. Everybody give it up for Samantha. Okay. So if we have a perfect square trinomial, that gets factored into a something squared. How do we figure out what that something squared is? Rebecca.
You take the x and the 5, and then you take the symbol from the middle.
Good. Good. Excellent. Everybody give it up for Rebecca. X plus 5 squared. Okay. Now, what about if we have x squared minus 10x plus 25? What is the only difference here as far as the factored version of this? Sloan?
The problem will become x minus 5 because the center.
Excellent. Everybody give it up for Sloan. All right. Okay, how are we doing on questions? Should we review? Clap if this is, well, unless you were absent. Clap if this is brand new. Okay, questions? How are we doing on questions? Okay, can I take this away? Are people still using it? Okay. So, we have one other option. We've gone through 2 terms, gone through 3. Do we ever have a possibility of having 4 terms?
Yes.
Yes, that's where we're going next. All right, so everybody have this? Okay. So the last one, again, 4 terms. So everybody be thinking about what can or should happen if we have 4 terms. So 4 terms. All right. Cole, is that a hand or no?
No.
Okay. That's okay. Aiden, did you have a hand up? Go ahead.
Oh, boy.
Okay, that's good. We can FOIL something out to get 4 terms. Alyssa?
There's like that box thing that you.
That's FOIL / box. You guys remember factor by grouping?
Yeah. Isn't that great?
That's good. Where you right. So what Desi said is we can factor by grouping. Let's start with 2 and 2. So if you have something like x to the 3rd plus x squared plus x plus 1. We have, so what does it mean? We have 3 different types of grouping. The first one says 2 and 2. What exactly does 2 and 2 mean? Desi.
The first two terms we factor, and then the next term we factor.
Excellent. Everybody give it up for Desi.
Okay.
Okay, so we factor them separately. We factor the first two terms together, find the greatest common factor, and then we factor the second ones together and see what the greatest common factor is. So if we're just looking at x cubed plus x squared, what can I factor out of x cubed plus x squared? Olivia.
X squared.
X squared, all right, everybody give it up for Olivia. Okay, what's left in the parentheses when we factor out an x squared? Amish God, is that a hand? Amish God is thinking. Does Amish God want us to wait?
No.
No. Okay. Aiden, go ahead.
X plus 1.
Good. Everybody give it up for Aiden.
Opposite.
Officer what?
Or don't.
Officer Ordonia. Okay, good. It is Halloween today. Lots of really awesome costumes in here. Okay, next one, Alyssa. Miss Cowgirl. A what? Excellent. Excellent. Everybody give it up for Alyssa. Cowgirl Alyssa. Now, so in this one, some of us may have been looking at that and going, okay, they have nothing in common, except a 1. Anytime they don't have anything in common, they always have a 1 that's in common, just like Alyssa said. So what does this actually look like completely factored out? Now that we have our work there. Cowgirl de Guzman.
X squared in parentheses, x plus 1.
Okay, and then x plus 1. Is that what you're saying? All right, cool. Everybody give it up for Alyssa. Okay, so this x plus 1 gets its own set of parentheses, and x squared plus 1 gets its own set of parentheses. All right, how are we doing on questions?
Where's your co-host?
My co-host. I think she went to make copies. I think. Okay, what if we have factor by grouping 3 and 1? Whoops. We're going to go dim. So factor by grouping 3 and 1. What's the difference here? I'm going to put one up in just a second. But what? So if I have something like x squared plus 6x plus 9 minus y squared. So the thing that should tip you off here is the fact that we have one random letter in there. That should be tipping you off like, okay, we're not going to have a grouping by 2 and 2. We're going to do something else. Amish God.
We are going to group by 3 and 1.
That's good. Okay, everybody give it up for Amish God.
Yeah.
So we group these 3 and we group this 1. So I'm going to cover up the 1 so we all can see the 3. So x squared plus 6x plus 9. What is that? What?
3.
Okay, good. Lorenzo says x plus 3 squared. Give it up for Lorenzo. Now, how did he know that? Barnaby? Barnaby. Everybody give it up for Barnaby.
Hey.
Hey. Okay, how did we know, or how did Barnaby know that this was a perfect square trinomial? Remember, there's a little test that we can do. Olivia.
Because 3 squared is 9.
Good.
X squared is x squared.
Good.
And 3 plus x is, I don't know if I'm saying it properly.
That's okay.
Blah, blah, blah. X times 2 times 3.
Good.
And it makes sense.
Excellent. Everybody give it up for Olivia. All right. So that's a perfect square trinomial. Now remember, there's something that happens with each of these squared terms. Anybody remember?
X,
Go ahead, Sloan.
I don't remember.
You go ahead. That's all right. Let's say a y squared. We have 2 sets of parentheses. How many go in each if we want to split it up evenly? 1 goes here, so we have 1y here and we have 1y here. What's the only way when we multiply these together that we're going to get a negative?
Plus and minus.
A plus and a minus. Cool. So can we use that same logic to distribute that x plus 3? Okay, so you tell me, what do I do with that?
So then you take x plus 3.
Uh-huh.
And then plus the parentheses, and then take x minus 3 to the other.
Okay, so this one actually, they're both going to be x plus 3, since basically we're taking this whole thing, distributing that whole thing into there. Cool. Everybody give it up for Sloan. Okay, but you do not want to have those innermost parentheses. I put them there so you all could see what was happening. So you want to write your final answer as x plus 3 plus y times x plus 3 minus y. All right, how are we doing on questions? Good? Okay, the last type of factor by grouping, we're going on the next page, is 1 and 3. We have not done an example of this kind yet, so this is super important. 1 and 3. I know, it's almost the same thing as 3 and 1, but backwards. So factor by grouping 1 and 3. So I'm going to ask you all in a minute what we think factor by grouping 1 and 3 means. And I'm going to put an example up here to try and illustrate that. So y squared minus x squared minus 6x minus 9. So, what do we think, Brandon? You actually do not necessarily want to do that in this case. Good guess, though. So if 3 and 1 meant we grouped the first 3 together and the last one, what do we think this one is? Rebecca? Cool. Everybody give it up for Rebecca. Okay, so we actually want to group these with parentheses. Because if you notice, all 3 of the last terms have a negative sign in them, which means what can we do with that negative sign?
Distribute it out.
Or, good, factor it out. Cool. And when we do that, everybody give Lorenzo Barnaby a round of applause. When you factor the negative out, everything changes as far as the sign. Okay? So, whoa, I'm having a mega deja vu.
I get this all the time, and I get my mug. Wait, what's the name?
Literally, like, you have the horns on, and Sloane's got the blue, and it's really weird. Okay.
Well, now I see how you view me.
Oh, that's so sweet.
Very. Okay. X squared plus 6x plus 9. How did we factor that in the last problem?
Huh?
How did we factor x squared plus 6x plus 9 in the last problem? Cool. Everybody give it up for Olivia.
Yay.
Okay? And then from this step, we had 2 sets of parentheses. Somebody tell me how I distribute that y squared. Sloan? That's fine. Go ahead.
It's a positive.
Okay. In this case, we're going to distribute 1 to each of them, right?
Yeah.
Okay? And then I'm going to keep working with me here.
Okay.
You agree? Would you agree that an x plus 3 goes in each set of parentheses? So 1x plus 3 goes here.
Yeah, but what are we going to do?
Okay. What's the only way to get a negative x plus 3 squared? That's okay. So 1 gets a plus and 1 gets a minus, just like you had in the last one.
Oh.
It's never going to be positive if you can factor it in this way.
Oh.
Okay? The last step, Shogi, I'll get your question in just a second. Remember, the last step is we do not want to have innermost parentheses. We have to distribute the negative 1 to what's in here. Does it matter whether we distribute the positive 1 to what's in there?
No.
No, because positive 1 times anything is whatever you started out with. So this becomes y plus x plus 3 times y minus x minus 3. All right. How are we doing on questions? Shuggy, you had a question. Yeah. A plus after the y squared? Yeah. Is it possible that it was like... I'm going to cover this up for a minute, guys. Is it possible that it was... So y squared plus 6y plus 9? Yeah. Oh, okay. So then you do it like this first one. Group the first 3 together and the last 1. There's probably a minus right here. I'll come look at it. All right, other questions related to the notes? All right, so as you guys are working through your homework, use this as a guideline, okay? You're going to get problems of all kinds, and what you want to do is start with every single one of them, start by looking for a greatest common factor and factor it out. Once you have done that, then you go back and look at how many terms you have. If you have 2 terms, you're going to be using one of the 2 terms types that we talked about. Difference of 2 squares, sum of cubes, difference of cubes. If you don't have 2, but if you have 3, then you're going to be using the diamond method or perfect square trinomials. And if you have 4, you are using one of the 3 types of factor by grouping that we just went through. Okay? All right. Everybody go ahead and start on your homework. And cheer! It's Halloween. You guys get to go have candy tonight.
Free candy.